Hello. I am Bjarne A. Magturo from MEC32 E03, and I will be talking about a problem that involves shearing stress and bearing stress. Now, for the problem, here, it is the lap joint shown in figure P126 is fastened by four 3/4 inches diameter rivets. Calculate the maximum safe load P that can be applied if the shearing stress in the rivets is limited to 14 ksi and the bearing stress in the plates is limited to 18 ksi. Assume the applied load is uniformly distributed among the four rivets. So the problem here involves the rivets here and two plates fastened together. Now, for the concepts involved here, this type of problem or this type of shearing stress problem is an exaggerated bearing deformation of plates. Now, for the shearing stress, it is a type of stress wherein the force applied is parallel to the area. Stress is produced whenever the applied load causes one section of a body to tend to slide one another. As you can see here, plate 1 and plate number 2 are adjacent to one another. Now, when a load is applied, one section of the body moves, causing stress to the other plates, causing it to move again. Now, both of them slides past one another because if one of them moves, the other one can also move. Now, for the bearing stress, it is the internal stress caused by a compressive force. Now, both plate 1 and plate 2 are compressed one another. They are compressed to one another by the four rivets here. 1, 2, 3, 4. And now, those four rivets will play a part in the solution later. Moving forward to the solution, I have already made the solution here and I have copy pasted it in MS Word so that it can be seen in the screen. Now, here, the main formula is the shearing stress formula, P over A, and the bearing stress formula, P over the area of the bearing. Now, before we proceed, it is important to keep in mind that we are required to calculate the maximum safe load P. Now, for the first part, we need to calculate the shearing of the plates. Now, P is isolated here. P is now equal to the shearing stress multiplied by the area. Moving on, P is now equal to 14 multiplied by 4 multiplied by 1 over 4 multiplied by the pi multiplied by 3 over 4 square. Now, 3 over 4 here, it is the diameter of the rivets given here. 3 over 4 inches diameter rivets. Now, pi over 4 multiplied d square is the common formula used when calculating the shearing stress of the rivets. Now, as you can see here, there is the number 4 multiplied or part of the area formula. Now, this number 4 here came from the given, which is the 1, 2, 3, 4 rivets. There are 4 rivets involved in the problem. And the 14 here, it is the shearing stress limited to only 14 ksi. Now, calculating it, we now got the 24.74 kips. So moving forward to the bearing of plates. Once again, P is isolated. P is now equal to the bearing stress multiplied by the area. Moving on, P is now equal to 18 multiplied by 4 multiplied by 3 over 4 multiplied by 7 over 8. Now, once again, we have seen 3 over 4 or 3/4. It is the diameter of the rivets. Now, the new number here is 7 over 8, which is also part of the given. It is the width of the plate here, 7 over 8 inches. And now, again, it is multiplied to 4, which corresponds to the 4 rivets used. 1, 2, 3, 4 rivets. And of course, it is multiplied to the bearing stress, which is 18 KSI. Now, calculating it, we finally got 47.25 kips. Now, as you can see here, there are forces, two resultant forces, 24.74 kips and 47.25 kips. And the final answer is the lesser one, which is the 24.74 kips. So the reason why we chose the 24.74 is because it is the lesser known force in two of them. That means 24.74 can be applied to the bearing without causing drastic changes into the actual plate itself. Now, why did we not why did we not choose 47.25? The reason is that the shearing of the plates can only withstand 24.74 kips, and when 47.25 kips is applied to it, it is not safe anymore. It can cause major changes or destruction into the actual system itself. So that is why the safe load, the key word here is safe. Safe. So the safe load P here is 24.74 kips. And now that would be all for the shearing stress problem. Thank you.